Hello, welcome to this walkthrough of question 14 from the Year 12 Pure Mock. Let's have a look at part A first. Well, initially t is 0, so v equals 8,000, e to the 0, of course, plus 2,000. Well, anything to the power 0 is 1, so we've got 8,000 times 1 plus 2,000. So the initial value of the speedboat is 10,000, which is a bargain, I would say. I don't know too much about speedboats, but that seems to me very cheap. Now let's look at B. Right, let's talk about the rate of change. It's decreasing. So first of all, we need dv dt. So you differentiate the model function and you would get negative 800 e to the negative 0.1 t. Well, we've got a particular value, uppercase T, when it's negative 200, it's decreasing. So negative 200 equals negative 800 e to the negative 0.1. Put a big T there. So you've shown that you can differentiate it. You know it's referring to the rate of change, and we've got to put it equal to negative 200. I do a bit of rearranging. Negative 200 over negative 800 gives me a quarter equals e to the negative 0.1 t. Okay, so negative 0.1 t must equal the natural log of a quarter, and t would equal 1 over negative 0.1, negative 10, but ln a quarter. Well, what comes out, if I put that into a calculator, you get 13.8829 with a load of numbers. So, but you need that in months, years and months. Well, I know it's going to be 13 years. But what you need to do is you need to do 0.8829 times 12 to find out how many months. And that works out as 10 months. Hopefully you're okay with converting a decimal number into years and months. So it's 13 years, of course, the 13. And then 0.8829 times 12 would give you 10 months. Or just a bit over 10 months, but we round to the nearest month. Let's just get a different colour for the next bit. C, well, what's the value of A? Let's have a think. Well, let's have a look at the function. 8,000 e to the negative 0.1 t plus 2,000. As t tends to infinity, the value is going to tend to 2,000. The reason being, as t gets really, really big, you get e to the negative of a really big number. That gets really small, very, very close to 0. So 8,000 times a number close to 0, something close to 0, and 2,000. So it will never go below 2,000. It's always going to approach 2,000. Hope that's clear. D, limitation. Well, I suppose the model doesn't really take into account things like wear and tear, or if you do a bit of damage to the boat, if I damage the boat to the boat, could affect the price. Could lower the price, shall we say. Because if I were, I don't know, driving the boat and I crashed it into the side, did a bit of damage, it would suddenly lower the value. So there's a lot of things like that. Well, let's just have a quick recap. Part 1, A. Part A, put t equals 0 into it. And that's your initial value, £10,000, which I believe is very good value. Well, I guess it's very good value. I don't have a speedboat. Then B, it's all about differentiating. You differentiate it, put it equal to negative 200. Rearrange and solve, and you get 13.8829, etc. Need to change it to years and months. C, well, what's the limiting value of the function? What happens as t approaches infinity? Well, e to the negative of a big number, it's going to get really small. 8,000 is going to become irrelevant because you're multiplying by a very, 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 very small number. So you're just left with 2,000. D, just a bit of a limitation there. Good one would be damaging the boat. If you damage something, it lowers its value. Hope that's clear and enjoyable. Thank you.